Hello everyone, welcome to Dinesh SQL. My name is Dinesh Priyankara, Data Platform MVP and Business Intelligence Architect. Let's talk about data science with relational database management system. Of course, we are going to talk about Microsoft SQL Server. Let's see how we can do data preparation, model training, and deployment within a SQL Server database. As usual, let me show you what I have added to this video. So let's see why we really need data science facilities within relational database management system. What sort of things we can do within a database. That's what we're going to discuss as the first part of this video. And then let's have a look on Microsoft machine learning products. What type of products are available and why we have to use them and where we have to use them. Then of course we are going to talk about SQL Server machine learning services. Next, let's see how we can get our database ready for machine learning services. What sort of things we need to add for example, holding models, and how we can get the models executed for prediction, things like that. And just like my other videos, the last part is going to be a demonstration. So I have prepared a demonstration based on predictive analytics, and we are going to talk about installing machine learning services as a part of SQL installation. And once that part is done, I'll be showing you how to do an experiment within a SQL Server, and then how this model can be built and uh, deployed within the database. Once that part is completed, let me show you how it can be consumed using an ASP.NET Web application. Okay, first part of it. Let's see the typical process of data science, and let's see whether data scientist actually can work within the database for continuing his processes. So generally data scientist needs data. Some of the data scientists, yes, they connect to the data source directly and they get data into their environment and then continue with the experiment. But in most cases, data scientist makes the request to the IT department saying, I want data from multiple sources. Or data scientists might not mention anything about the data source. Data scientists might say, okay, I need a data sets related to sales. I need data sets related to last promotion we did. So it's IT department duty to get the relevant data from relevant sources and then apply whatever the transformation required, for example cleansing, validation, aggregation, things like that, and send the result to I send the result to data scientists. It can be a simple request or it can be a very complex heavy request where we see that IT department has to spend days or weeks. However, once data scientist has the data set, he will be using his own environment, things like Jupyter Notebook, Eclipse, or some other platform for continuing with his experiment. Once the experiment is done, he will be converting his training experiment to a predictive experiment or the predictive model. We all know that this is not going to be the converting the training experiments to predictive experiment is the last part of this process. Data science process, all the machine learning processes are never ending processes. It has to be iterated. Data scientists will continue this process in order to improve the efficiency of his model created, or in order to improve the performance of his model created. So when this when this iteration happens, he needs data again and again. That's add an overhead to IT department. As I told you, if it is a very simple data extraction, we don't need to consider it as an overhead. But if it is a complex, heavy requirement or heavy request, then IT department has to spend their resources again and again, which can be considered as an overhead. Not only that, this hinders the performance of data science process. Data scientist has to wait. If IT department takes days or weeks for getting data again, if it is the same request, for example, let's say initially data scientist requests data related to sales and then the sales data has to be extracted only from one source, one table, then we don't need to consider it as an overhead because IT department has codes written for the previous request. But if data scientist says that, okay, I want these new elements, these new records, new columns, new entities as a part of the result set, then IT department will not be able to use existing codes or the codes written for the previous request, which means IT department has to reinitiate the whole thing. That will surely hinders the performance of entire data science process, and data scientist has to wait. But what if data scientists can work within the database, within the data source? He doesn't need to talk to the IT department. He logs into the database and then he extracts data as he wants and continue with his experiment. We are not going to talk about all sort of data sources. We'll be completely focusing on Microsoft SQL Server. So let's see how data scientists can work within the database in terms of getting data into his environment and then doing the experiments or performing the experiments for creating a predictive model. Let's see what sort of things can be facilitated, what sort of things can be satisfied within the SQL Server environment. Before we talk about data science within a database or data science using SQL Server machine learning services, let's try to understand Microsoft products related to data science. The first part shows products or the services available as a part of the Azure. Second part shows on-prem products. So let's focus on cloud services. We have two: Azure Machine Learning Service and Azure Machine Learning Studio. Since most of us started with Azure Machine Learning Studio, let's talk about Azure Machine Learning Studio first and then move into Azure Machine Learning Service. Azure Machine Learning Studio is a very simple environment which can be easily used for data science experiments. So it has a graphical interface. You can simply drag and drop ready-made items including algorithms for creating your flow for experiment, and then you can use it for testing, evaluating. If the evaluation is really good, if you're happy with the result, you can promote your training experiment as the predictive experiment. Not only that, Azure Machine Learning Studio environment supports for hosting your training models as web services. So if you have a requirement for testing data science, or if you have a requirement for simple, not that complex, you can use Machine Learning Studio. One thing you need to remember is you can actually use both Python and R with Azure Machine Learning Studio. Now let's go for Azure Machine Learning Service and see what sort of things we can do with it. So just like the Machine Learning Studio, it's a managed service that can be used for training, deploying, and managing machine learning models. But one thing you remember is it doesn't support both Python and R. It supports only Python, but it is rich with certain open source technologies, and it has multiple tools for performing experiments. For example, it has TensorFlow, PyTorch, scikit-learn, and in terms of the tools, it has notebooks, both Azure Notebooks and Jupyter Notebook, and it has Azure Machine Learning for Visual Studio Code extension, which means you can use Visual Studio for doing all these experiments. So it is not just for simple non-complex experiments. You can use this environment for both simple and complex machine learning or data science experiments. Now let's talk about on-prem support. So we have two things: Microsoft SQL Server Machine Learning Services and Microsoft Machine Learning Server. So let's talk about Microsoft Machine Learning Server with this slide, and then we'll talk about SQL Server Machine Learning Services in detail with the next set of slides. So what is Machine Learning Server? All you have to know is it is an enterprise server for hosting and managing parallel and distributed workloads of R and Python processors. So you can use this environment specifically in on-prem environment for processing very complex experiments using Python and R. And the good thing with this is you can host this in Linux, Windows, Hadoop, or even in Apache Spark. And if you really want to have this as a part of your cloud or in Azure, this can be configured as a part of HD Insight. Just like the Azure Machine Learning Service, this has enough of open source technologies, And in terms of development environment, you have R tools for Visual Studio and Python tools for Visual Studio. So you can simply perform your experiments and use this for deployment hosting as well. Now let's talk about SQL Server Machine Learning Services. So what is Microsoft SQL Server Machine Learning Services? You can think it as a facility within SQL Server that can be used for performing data science experiments using Python and R. You don't need to go outside. You'll be doing this experiment within your user-defined relational database. Let's try to understand some of the features, characteristics of SQL Server Machine Learning Services. So as I told you, it allows you to execute Python and R code within your relational database for performing experiments, and execution happens within the database. You don't need to have an additional environments for executing these codes. You have these Python and R languages from standard packages. For example, Python is available as a part of both ReverseScale Pi and Microsoft ML, and again R is available as a part of ReverseScale R and Microsoft ML. So you can use all the functionalities, properties, methods available with these packages for performing your experiments. Not only that, it has some other open source packages and the frameworks such as PyTorch, TensorFlow, Scikit-learn that can be used for the experiments. What sort of experiments we can do with SQL Server Machine Learning Service? We can do a classification for categorizing or identifying the class related to certain records. For example, if you want to categorize customers based on predefined categories, this can be used. We can use for regression, and we can use for regression if you want to predict some numeric values. For example, sales revenue, the customer base, if you want to predict it, that can be done within the SQL Server database. You can detect exceptional cases, odd records, that's as a part of anomaly detection, and you can perform experiments related recommendations as well. So do not think this environment as a fully fledged environment for data science or the machine learning experiments. This has some limitation, but the good thing is you can do all these listed types of prediction within your SQL Server database, and you don't need an extra environment for performing these. How this works, or how we can get our database ready for data science processes. So the assumption we are going to make here is, or with this video or with this discussion, data required for data science process is available within the database. We know that in most cases we have to get data from some other sources as well, but if we want to extend this conversation, we can talk about Polybase. We can see how we can access external data sources within the database by using Polybase, but we are not going to make this conversation complex like that. So the assumption here is data required for the data science experiment is available within this database. So let's say this is the table we want to access in order to get data for data experiment. First thing we have to do is we have to write a stored procedure for completing or performing this experiment, and saving this experiment or converting this training experiment as a predictive experiment. So I can write a stored procedure that has either R or Python code for testing, evaluating, and then promoting it as a predictive experiment. So I'll be getting data and then completing my model. Once I'm satisfied with the evaluation, which means it can be converted from training experiment to predictive experiment, where can I save this predictive experiment? Because we have to reuse it. That's how we use it for prediction. When it's come to SQL Server Machine Learning Service, what we do is we create another table, the standard SQL Server data table, for storing these trained models. I'll show you the code that can be used for saving these models into one of the tables. But the whole idea is you do the experiment, and once everything is done, you'll be using a SQL Server data table for storing these models. Now we have the model that can be used for prediction. So let's say we have an application with its Windows based or web based, and you get some input and you need to pass this input for this trained model. So how do you do it? We need another stored procedure. So application calls this stored stored procedure, pass the input, then the stored procedure communicates with the model table. It gets the required model because this will can hold multiple models, one for classification, one for regression. Likewise, this will has multiple models. So this stored procedure has to make the right call, and it takes the model from the model table, and then it used for prediction using with the input received from the application. So once the predicted value is generated, produced, that can be sent back to the application. So this is how it has to be done. So as you see, data scientist does not go out of the data source environment. He can perform his experiments within the SQL Server or within the data source, and then he can save the model within the same environment. So what about retraining? That's really simple. So as a part of the business process, we need to make sure all new data is getting stored with your source table, and anytime we can call the first stored procedure for retraining and saving the model again. So this simplifies the entire operation. But as I mentioned before, this is not for very complex data science projects. If you can implement your experiments using relational data within this relational database management system, and your experiment is only for the discuss predictive types, then this environment is the ideal environment for implementing your data science experiment. Let's see how we can setting the whole thing and starting our data science experiment. Okay, first thing is you have to do the installation. So I'm not going to take you through the entire SQL Server installation process. I believe that everyone is familiar with SQL Server installation process. But one thing we need to remember is, if you want to have machine learning service or if you want to perform data science experiments, you need to make sure you select either Python or R as a part of machine learning service in database. So just make sure you select either both or your preferred or familiar language when you do the installation. So that's the first thing. Second thing is there are actually two things. Once the installation is completed, you need to make sure your database management system supports for executing external scripts. So what are the external scripts? Python or R. In order to execute, you need to configure your environment. So we generally use sp underscore configure for enabling, disabling server level settings. So just like that, you just call sp configure and pass the value as external scripts enable with 1. And once it is done, you need to reconfigure it. You might have to restart the service. Optionally, you can install a development environment for writing R and Python codes. One thing you need to remember is, when you write R or Python codes within your SQL database, it has to be submitted as a string. So it looks like you're coding in the notepad. This is what I advise. Uh, Rather than writing these Python or R codes in your query window, it is always better to use a different tool, for example Azure Notebook, Jupyter Notebook, and then write your experiments. If you want, you can test it and then take the copy of it and put it to SQL Server database. Next is create the table for holding models. Generally it needs 3 columns. The first column is the ID, which is going to be the primary key of it, and the name of the model, and verb binary column for holding the model or the predictive model. So that's the third column. In addition to the third column, you might have to create multiple columns for holding supportive objects related to the model. For example, let's say as a part of your experiment, you use scale object for normalizing your numeric values. In order to predict, you need to make sure you use the same object you use for experiment. So it has to be saved as well. In that case, you need to have additional columns in the table. That's why I have created additional columns. So there is no rule saying you need to have 3 additional columns or 5 additional columns. Based on your experiments, you have to have additional columns, because whenever you call for prediction, your second stored procedure will take both model and supportive objects for producing the prediction. So just make sure that you have created this table supporting all required columns. This is a stored procedure for performing the experiment and saving the object. So as you see, we have multiple output variables. Why? Once this stored procedure is executed, we need to take the model out as a binary variable plus additional objects. So you will be having multiple output variables based on the objects you use with your experiment. And then you start with sp execute external script stored procedure, because that's what you use for submitting your Python or R code. We are not going to discuss the code written for the experiment because the video is purely for understanding how we can do data science within the SQL Server database, not for discussing how we perform predictive analytics using Python or R. But just to explain some of the things I have written as a part of this code, uh, I'm getting data from customer credit data table, and then I'm saving it as a credit, and then you do the standard coding for your experiments. So I'll be creating labels array, and I'll be creating some objects for encoding, and finally I'll be calling one of the algorithms. But one thing you remember is you have to use multiple algorithms and then evaluate and see the result and then pick the best. So assume that I have already done it and I have decided to go ahead with decision tree classification. That's what you see with this screen, and I'm happy with it, so I'm going to save it. How do I save it? You can use pickle for saving it. So the result of the pickle operation is saved to train model output variable. That's how we take the model out and see some other parameters we use with the stored procedure. You notice that I use a table name called customer credit data. Actually, it is related to the SQL query I have written, which is held with input underscore data underscore one variable. And since I'm passing parameters for sp execute external script stored procedure, I need to make sure I mention all my parameters with params. I'll show you the entire stored procedure as a part of the demo, but this is how you configure your stored procedure for performing the experiment and saving the object. Once it is ready, you have to call the stored procedure and the result has to be saved in the table you created. So the first part of this code shows the way of calling the stored procedure, passing output variables, and then we delete the existing record in the model table because we don't need to have two records for the same predictive model. So you delete it and then you insert a new record with the output you received from the stored procedure. So that's how you save your predictive model to the table. This is a stored procedure that will be executed by the external application. For example, if you have a web application will call this stored procedure by passing inputs. Let's try to understand some of the codes written here. So the first thing is we need to get the model from the database. That's what you see with the first select statement in this stored procedure. So application will pass the model name. I can simply filter my model table by using model name column, and then that model will be passed into my Python code. As you see, we use sp execute external script stored procedure again for prediction, and I use pickle for loading the model again, and then I call predict method for performing the prediction. Once I have the result set, I'll be taking it out from my sp execute external script. So that's how you use a save model for prediction. Okay, so let's see how everything works. I'll be showing you an application like this. We'll be passing some inputs. I'm going to use one of the famous data sets, which is called German customer credit data set, and I'll be having that data set saved in one of my SQL Server databases, and I'll be creating required stored procedures for performing the experiments, saving the model, and then creating another stored procedure for calling that save model for prediction. And let's see how we can call that stored procedure using the web application. Before I show you the code written for the data science experiment, let me show you what sort of experiment we do. So we have this data set. This is the customer credit data set, and it has multiple customer records like customer ID and various values, various attributes related to customer. At the end, we have an attribute called bad credit. So whether this customer has some sort of history related to bad credit or not. Okay, so the plan is use this data set for prediction. So whenever a new customer comes, we don't have a value for the last column, but we will be having values for all the other columns. So we should be able to take new values, pass to the machine, and get the value for this. So this is what we are going to predict. The bad credit is the one we are going to predict. So we'll be using this data set for training. We'll be asking machine to find a pattern between these all these inputs and this output, and then if it is really good, we'll be using it as our predictive experiment. Okay, so that's the data set. Okay, here's the code. The first code is for creating the table. I have already created this table, but let me take you through the code. So the table is going to be named as models v2. I have named this as v2 or the version 2 because I have multiple versions of this implementation. So the model table contains multiple columns, but the most important columns are these two columns, model name and the model. So we'll be holding the model created using this column. In addition to that, as I told you, we need to have multiple supportive columns. So all supportive objects that will be created within the experiment, those will be saved inside this table. So that's why I have multiple columns like this. So this set of columns is purely for uh, storing objects that have been created for categorical column. I'll be using one hot encoding for transforming data, and I have another column for holding the scale object I use for handling numerical columns. Right, so this is the table. uh, I have already executed my stored procedure and inserted couple of models. So if I execute the select statement, you'll be able to see the models that have been already saved. So you can see one model, and this is the second model, and this is the model, and all these are binary columns. That's why you're seeing values like this. Right, so this is the first table. Now let's see the stored procedure that has been created for creating these models. So let me open the second code, and this is a stored procedure. So uh, the stored procedure name is build customer credit model version 2, and this has multiple output parameters. Why? This stored procedure creates the model, and I need to take the model out, and I want to I want to store that model in my table. So in addition to the model, I'll be taking all the objects I have used within the experiments using these output parameters, and then I'll be saving these parameters as well. So let's go through the code. As I explained, in order to execute your Python code, you have to use sp execute external script stored procedure. So within that stored procedure, you have to have your Python code, or if you're writing the code using R, you'll be having your R code within this section. So this has multiple parameters. The language I have mentioned as Python, and the script, this is my Python script. Before we are going through the Python script, let me scroll down and show you the other set of parameters. So these are the other set of parameters. Now all these parameters are output parameters because this script returns the model and the other supportive objects. So I need to capture them and put it to my SQL variables. That's what we do with this highlighted code. But see these three parameters. First parameter is all about a select statement, and second parameter is a name for a result set. So as you see, it is customer credit data. And the third parameter is all about the parameters I'll be passing to my script. So these are the parameters. So those parameters have to be mentioned with parameter. Okay, now what is this script? This input data one script. If I scroll right, you will see that it is from it is a select statement, and the data is taken from customer credit data. So this is the data set we have to use for training. So what I'm going to do is I'm going to use this select statement inside my Python script. Actually, Python script will receive the data set based on the select statement, and I'll be naming that data set as customer credit data. That's how you need to understand. So this query will be executed, the result will be saved as this, and this result set, this data set will be used within the Python code. Now let's have a look on the Python code. Okay, so we are not going to discuss everything in detail, but I'll take you through certain important sections of this Python code. So this section is for importing all required libraries or the packages, and then I access the data set. So customer credit data, that's what we get from that select statement. So this credit variable holds all data that can be used for the training experiment, right? Since this is the regression type of experiment, I need to take the labels credit, the credit or the that credit field or the attribute is my label, and all other columns are my input. So if I take you through one section like this, we have a column called checking account status in my input data set. So it's a categorical column that has to be transformed, or you can consider this as a part of feature engineering. So I use one hot encoding for a transformation. So at the end, the value of this column or value of this attribute will be transformed, but the object I use has to be saved. So at the end, I'm going to use this object. And I'll be saving this object with my model table. Uh, so uh, so the result of this code will be added to an array called features. So likewise, I'll be transforming each and every column. So there is a code for transforming each and every categorical column, and at the end, I'm adding all my numerical columns as well. Then if you are familiar with the standard data science project, you know that you have to split it, and part of it has to be used for training purposes, part of it has to be used for testing purposes. So this is the code for splitting and organizing data sets as training, X training, Y training, X test and Y test. And before we start the training, I apply a standard scalar for all the numerical columns. That's why you see this range, and this is the object we use for this transformation, and that will be saved with our model table as well, right? And once everything is done, basically the feature engineering part or the transformation is done, we can call the relevant machine learning algorithm for performing the training. So as you see, I have used decision tree classifier for continuing with this experiment. You can see another code which has been commented out, and that's another test I have done based on logistic regression. So you know that when it's come to data science, we use multiple techniques for testing and trying to find the best algorithm for the experiment. So that's what I have done, but we are not going to do that type of test as a part of this demonstration. So assume that I have done that test and I have picked this algorithm. So this is my algorithms. So I'm performing the training part, and at the end I save the model to this variable using pickle. Okay, so that's what I have done. In addition to that, I use pickle for taking all the objects I have used for transforming my categorical columns and transforming my numerical columns. So at the end, I have the model with this variable, and I have all other supportive objects with these variables. Okay, so that's what I use, or those variables are used with this part for assigning values to my output variables. So at the end, if I call this stored procedure, I'll be getting all the values through these output parameters. Okay, Now let's see how we can call this stored procedure. So let me open my third code. So how do I call the stored procedure? Because stored procedure returns stored procedure returns values for the model and supportive objects. So first thing is I need to declare variables. I'm going to use these variables for holding uh, values that will be returned from my stored procedure. And then I execute the stored procedure, passing all my output parameters. And at the end, I get values for these, and I'll be inserting the record to my model table. So what I can do is I can if I want to drop the existing model, then I can perform delete statement and insert, or else I can insert this as a new model. So let me say model 3. So I'm going to comment out all of this. So I'm going to execute this code, declaration, variable declaration, and then stored procedure execution, and the result will be inserted to model 2. So let me execute. Now we are calling the stored procedure, which has been written for performing the training experiment. Now it is done, so we can check the table and see whether a new record has been added. So let me go to my first script and execute the select statement. I can see 3 records. So this is the model we just saved. Now again, we didn't discuss much on this Python code because it is not something we wanted to discuss with this video. But this is how you sorry, this one. So this is how we do the training experiment within SQL Server and get the model out and save it in one of our tables. Okay, so the first part is done. Now what we have to do is we need to have another stored procedure which can be used for calling that model and perform the prediction. So this is the stored procedure. So I have named this as predict customer credit risk version 2, and this accept the model name. So if application is calling this stored procedure, it has to pass the model name. And do not worry about this part. It is basically this is what I plan. Application will capture all information through its data entry form, and those information will be inserted to a temporary table, which is my data table, and then that data table has a unique ID for each and every record. That ID has to be passed to this. So this stored procedure will access my data table and get the input values. So how it accesses the table and gets data using this unique identifier. So it gets data from that table and then pass it to my model, perform the prediction and get the result, and the result will be sent through this. So let's try to understand the code. So just like the previous time, I need to have multiple variables for holding my model and all supportive objects, and then I'll be loading the model and the supportive objects from my model table based on the model name that has been passed. So application says that I want to use this model, and that's what I get through this model name parameter, and then I can execute this statement and get all required objects loaded to these variables. Right, now we have everything. We are going to call the Python script again. Now this requires inputs. So as I told you, application will first insert all the inputs to data table. So we need to get those inputs from the data table. So this query has been written for that. So you can see it is getting data from data table based on the data ID that has been passed as a second parameter. And this query will be executed within this external code. Now this external code part is just like the previous one. Language is Python and we have the script, and if I scroll down, you will see that I'm passing the query, which is a select statement that has been written against my data table, and the data set will be named as customer data and the parameter list. So we have this list. So let's see, let's have a quick look on Python code. So it loads the model based on this. So this is coming from my parameters. Let me scroll down and show you. You can see the parameter name, So we assign the model which has been taken from my model table to this parameter, and we are using that parameter inside the Python code. So we use pickle loads method for loading that model, and this is our model. Okay, so next step is get all the objects initiated. Do not worry about this code, this has been commented out, so let me delete it anyway, so you don't need to worry about that code. So we have loaded the model, and then we load all the supportive objects. We have already received those objects using the parameters. So I load all required objects, and then use those objects for performing the transformation against new inputs that we have received through data table. So all objects are initiated. So once everything is loaded, we can call the predict method. So this is the predict method. So we call predict methods by passing all transform items, and the result will be saved with credit risk variable. So what we have to do is we need to access the first value of the credit risk, because it's an array, and assign to each risky parameter. So if I show you my parameter list, you can see we use the value coming from each risky to this output parameter, and that will be sent to the application because it is an output parameter. So this is how the stored procedure is getting called. Now I can show you the application, but before that, how do I test this? This is how I test it. I have already inserted multiple records to my data table. So let me show you the table. So it has multiple IDs. So I can pick one of the IDs. So this is the first ID, or it's not the first ID, it's the second ID. So I can call my stored procedure, I can pass the model name, I can pass the ID of this input, and check and see whether we have a risk by granting a credit for this customer. So let me execute this code. So what happened is stored procedure goes to the model table, picks the model table, and then it uses input data based on this ID, and then it predicts. So it says false, like it says no risk. I can do another test with a different record. It might gives us 0, or it might gives us 1. So likewise you can get the predicted value using this code. Okay, now let me show you the small application I have written for testing this. So this is just a data entry application. It captures all the information, and once everything is captured, I can click on this button. I'll show you the code. So what happen is whenever I click on this button, it capture the information that has been entered through these input boxes, and then it pass it to my data table. Okay, so once everything is saved in my data table, I get the primary key of it, or the unique ID of that record, and then I'll be calling my second stored procedure by passing the model name and this ID and the output parameter, which will give me some sort of idea on the credit risk. For example, I can enter some data. So let me pick something I have already entered. I'll be randomly picking things. So all good, and let me say rent, and loan duration, let me say 36. So assume that we have a new customer, and we are entering all inputs, and we need to check and see whether this we need to check and see whether we can give a credit for this person or not. So let me say 2%, and age is 35, right? So when I click on this button, data will be inserted to my data table, and then the second step of that method is calling the stored procedure. So stored procedure will go to my model table, it picks the model, and it uses input data to do the prediction. So let's see the result. Okay, so I got the result. It says grant credit. So this is based on the output parameter. Let me quickly show you the .NET code I have written. So it's a simple code, and it calls my stored procedure by passing all these values, and at the end I capture the output parameter, and based on that I show the message. So this is how you do it. It's a standard way of calling a stored procedure. Okay, so that's all we have. So hope you understood the way of doing data science experiments within SQL Server. If you have any question, you can put a comment, and then I'll try my best to reply as soon as possible. Thanks for watching.